I wanted to give a demonstration of finding a product of sums expression for a truth table. So here's my example truth table. It has three inputs, A, B, C. I have to write out all the possible Boolean values. I'm using zeros and ones, and I start with 0, 0, 0, and end up with 1, 1, 1. I do work in a counting order. That doesn't matter. But I have some particular output. So this is what can change. The input side is almost always the same if you're interested in all the possible inputs. And then the output changes from scenario to scenario. So this is just some particular scenario. Then we want to write an expression for it. Now, the Boolean expression is not unique. You can write it in different ways. So this is a way to write a Boolean expression. And in the product of sums approach, you focus on the outputs which are zeros, and you are going to write a sum expression, and the analog of sum is ORing. So somehow we're going to make an expression which is A plus B plus C. Now I'm going to do a little bit more, but let me copy that in. I'm only working with the zeros. I'm only working with the zero outputs. Okay, those are not the expressions. I'm not done yet, but we're working with a sum expression, but plus really means or in this notation. And I want to write an or, a sum expression or an or expression, which would be a zero in this row. So we know that an or gives a zero only when all of the inputs to the or are zeros. Okay, so the A was a 0 and the B was a 0, but the C was a 1. So I'm going to invert that C so that it would be 0 or 0 or 0. So this C will get primed. Again, the OR gate gets a 0 when all of the, as an output, the OR gate gives a 0 when all of the inputs are 0. And I want an expression which is a 0 for this row and 1 for all the other rows. And so I need to make the inputs into zeros. So A was already a 0, B was already a 0, but C was a 1, so I had to invert it. Again, next I only do the zeros. So here A was a 0, so that was good. But B was a 1 and C was a 1, so they need to be primed. Here the A was a 1, so it needs to be primed. But the B and the C were zeros, so they were good as is. And then down here in this last row where the output is a 0, the A is a 1 and the C is a 1. So those are our sum expressions. The analog of sum in Boolean is an OR, so this is an OR expression, a 3-input OR expression. And when you see on a given row, if the input is a 1, that's when you must prime it, because we're trying to create a 0 for that row with an OR gate, and an OR gate is 0 when all of the inputs are 0. So when you see a 1, you invert it so that by the time it gets to the OR gate, it's a 0. Okay, so now I'm going to write the product of these. So I'm going to write A plus B plus C in parentheses. I'm going to come back and do my primes in a minute, but I'm going to copy that. I have 4 terms, so I need this 4 times. Okay, so we have the same kind of precedence in Booleans that we have in normal algebra, and that is if you want to do summing, ORing, before you do multiplying, which is ANDing, then you need to put it in parentheses. So the normal precedence would be to do multiplication first, but if you want to do the summing first, and we do, then you will need the parentheses to enforce that. And then I need to go in and put my primes in where I have them above. So the C was primed in the first term, B and C in the second term, just A in the third term, and in the fourth term, A and C. So it is a product of sum. So we write a sum expression only when the output's 0, and we are writing an expression in which we are trying to force it to be a 0 in that row. So if the input for that row is a 1, then we invert it, forcing it to be 0 so that all of the inputs to the OR gate are a 0, giving us an expression for that is 0 in that row. And then we write a product of those expressions using the parentheses to take care of our precedence, our order of operations, and then just a vocabulary term. Another way to say product of sums is to say we want the max term. Okay. At this stage now, I would like to go to a gate version to sort of build this, and I'm going to use National Instrument Multisim. So I'm going to start with a file I have sort of pre-built called switches, and it gives me, in this case, 4 switches, A, B, C, D, hence the name switches. And the switches are connected to a high end of the battery. So I color-coded the red to be connected to the 5 volts, and the 0 volts, which is grounded at the bottom, to be black. And then each of these switches is connected that there's a high and a low. So these A, B, C, and D can be high or low. And then I've also inverted all those inputs. So this blue line corresponds to whatever A is, and then the next line, that red line, is A prime. It's the opposite of whatever A was. If A was high, then A prime will be low, and vice versa. And I have that for A, B, C, and D. Now, my example only had A, B, and C, so I certainly don't need the D. But this is just something I had pre-built, and so it's convenient, so I'm going to use it. This part of the logic is sort of always the same, like that you may need A and A prime and so on. And then the difference from scenario to scenario comes in how you connect from this point on. I need 1, 2, 3, 4 3-input OR gates. That's my next step. So I'm going to go to Place Miss Digital, and I want 3-input OR gates, and I am asking for 4 of them. Now I'm getting a little crowded down here. One thing I want to do is right-click just out in space and choose Properties, and go to the workspace and give myself, change the height a little bit here, maybe to 10. That made my workspace a bit bigger. Now I highlighted those. I'm going to arrow down and make these wires a little bit longer. That's going to allow me to spread out these OR gates a little bit. So I have these, there we go. That should be sufficiently spread out. I had 4 sums. I had 4 zeros. So I had 4 sums, and those sums were of 3 terms. So it's the sum is a 3-input OR. I have 4 of them. I'm going to make a product of them. A product, the analog of a product is an AND. So I'm going to AND together 4 things. Back to Miss Digital, find the AND gate, which is 4 inputs. That's here. And then I'm going to want a probe. That's under Place Indicator, and I'll take green probe this time. I'm going to connect to the probe, to the AND to each of the ORs, because that's sort of almost mindless. And then we have to think a little bit more when we're connecting to see if we're connecting to the prime or the not primes here. So here's the product of the sums. Now let's get the sums. Let me sort of put this where I can see it while I'm working on it. Okay, so the first one is A, B, and C prime. So there's A, there's B, and then I'm going to C prime, which is there. The next one is A ORed with D prime and ORed with C prime. So that is again A, B prime, is here because it's A prime, B prime, and then C prime, which is here. A prime, B prime, C prime. The third term was A prime this time, so that is here, and then B and C. So there is B and there is C. So it's A prime, B prime, C prime. So this was A prime, B, C. That's what I wanted, A prime, B, C. And the last one is A prime, and B and C prime. So that was here. A prime, B prime, C prime. Okay, and then we can test it if we want. Let's say we want to test this row where A is low, B is high, and C is low. So A high, which we have, and no, I wanted A. Let's pick this one, A low. So I should switch the A low and the B high and the C low, which it is. And of course I should turn it on. That would help. And so then that row where A was low, B was high, and C was low should be a 1. But if I switch the C to high, then it should, the probe should go off. So there's my probe. Now I'm low, high, high, low, high, high, and then the probe is off. You sort of barely see that it's just barely made it on the screen there. So that is a product of sums, also known as a Maxterm. So you focus on the zeros in the output of the truth table. You write an ORed expression. You're trying to create a 0 for that row. So when you see a 0, you leave it, but when you have a 1, you invert it. So the inverse, the prime, goes with the 1s in this case. And then you take your sum expression and write a product of them. You have to respect your order of operations, your precedence. So you need parentheses around your sums to make a product of them. And then this sum corresponds to an OR gate, and the product of them corresponds to an AND gate. So when you're building it in gates, then you need the corresponding OR gates first and then the AND gate. Okay, that's what I wanted to show you. Thanks very much for your attention.